Hi everyone, this is KC6 on functions derived from linear and exponential functions for integrated 2. Okay, so we are going to start with section 1.1, which is on transformations of absolute value functions. Now, an absolute value function is talking about distance, okay, in particular. Absolute value is never going to be negative, so it is always positive. Okay, so you usually use the absolute value sign. It's two lines and you'll have numbers in between there, or you might see a function with absolute value inside or outside of those. Okay, and that just means what is the distance from 0 on a number line of that function or that number. Okay, for example, the absolute value of -5 is +5 because the distance from -5 to 0 on a number line is 5 units. Or 5 itself is again also +5. Your answer is always going to be positive when you have an absolute value, okay? Doesn't necessarily mean that when you have absolute value of functions that's always going to be positive, because it's not. All right, we also need to talk about parent function. So a parent function is the general function to absolute value. So this one is going to be f of x is equal to the absolute value of x. Okay, now to find this graph or to see this graph, I'm going to show you guys a table of values. Okay, so I'm going to choose random numbers. I usually go with -2, -1, 0, 1, and 2 because those are usually the easier ones. And what I'm going to do is I'm going to type this function and see what I get. Okay, substitute. So if I put absolute value of -2, my answer will be 2. So that means that my coordinate when I graph this point is at -2, 2. I'm going to do the same thing for all of these numbers in my table of values. So if I plug in -1, I get a +1, so that coordinate will be -1, 1. If I plug in 0, absolute value of 0 is 0. So I get 0, 0. Absolute value of 1, again, is +1, so I have 2 1s as my answer here, and that's okay. And then last but not least, 2, which is 2. So I get 2, 2. So now when I graph this, you'll see or notice that it looks, let me see. I want you guys to be able to visualize this. So at -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. It will look like a V. Always. Okay, so every time you have absolute value inside an equation, your graph is going to look like a V. So this is our parent function, okay? We are going to start all of our transformations from here. All of our transformations are going to start from 0, 0. Okay? And we are going to transform this by using the regular function, or general function, of f of x is equal to -a times the absolute value of x minus h plus k. Okay, now all of these letters and signs mean different things for absolute value functions. Okay, so we're going to start right in the beginning. This negative means that my graph, my parent function, that's the one that we just drew above, is going to be reflected over the x-axis. So if you have an equation where you see a negative in front of the absolute value, that means that your v literally flipped upside down. Okay, now a, you have two different things. The first one is if the absolute value of a, whatever that is greater than 1, then it will stretch your graph. So it'll be wider. And if the absolute value of a is less than 1, then it is going to shrink or get narrower. Okay. H, there's two things to this. This is either going to move left or right, but whichever direction is depends on this sign right here. This means that you are going to do the opposite. Okay, so usually negative numbers are on the left side and positive numbers are on the right side. So if you are adding some number here like +5, then you're really going left 5. If you're subtracting something like -3, then you're really going right 3. So you have to remember to do the opposite here. And then last but not least, K will go up or down. You don't do the opposite. It is just up or down because it is not inside the absolute value. So the one that's inside the absolute value is the one that you do the opposite for. Okay, so using that, we are going to go ahead and complete these problems. So all we're going to do is describe the transformation. So all I want you to do is to tell me, did it go left, right, up, down, did it reflect, and by how many units? Okay, so number 1, f of x is equal to the absolute value of x plus 3. So this is inside, and if I look at my general function from above, that means that it goes left or right, but you have to do the opposite. So this is going to be a +3, which means that it usually would go right. So the opposite of that would be to go left 3 units. That's it. That's my answer. That's my transformation. From 0, 0, all I have to do is move 3 units to the left, and I can write or create my new graph. All right, next one, -5 on the outside. So this is not the opposite, and the outside numbers tell you whether it goes up or down. So this is going to go, down 5 units. And that's it. Next one. I have a negative in the front and this 2. So this negative and the 2, there's going to be 2 different transformations here, and you can have more than one. Okay, so the first one will be a reflection, so it reflects over x-axis, and the other one will be left 2 units. Now it doesn't matter what order you write these in. If you write this one first, that's fine. I don't care as long as you have both of them on there. And last but not least, I want you to go ahead and pause the video and try it on your own before I go over the answer. Okay, so here you have 1, 2, 3 different transformations. So first one I see is a reflection, so it reflects over the x-axis. Second one is at 4, which is going to go right since it's the opposite. And then the last one is going to go up 6. That's it. Now, you should be able to describe those transformations and graph the new graph as well. Okay? And all you have to do, again, is you start from 0, 0, and you do those transformations, and those will be your new points. Now, example number 5 says, given a function 2 times the absolute value of x, you want to complete the table of values and graph that, because I want you to see how this number changes that graph from the parent function. Okay, so all I'm going to do is wherever I see x, I'm going to plug in my number for my table of values. So I have 2 times the absolute value of -2, which gives me 4. Okay, so absolute value of -2, remember, is always positive. That's a 2, and then 2 times 2 gives you 4. So I get -2, 4 as my first coordinate. And do that to all of them and see what you get. Okay, so go ahead and pause this video and finish them before I finish all of these here. So I get -1, 2. Plug in 0. I get 0, so 0, 0. Plug in 1. I get 2 again, so 1, 2. And then plug in 2, which I get 4 again. Okay, so I'm going to graph these points now. I have -2, 4, which is up here. -1, 2, 0, 0, 1, 2, and 2, 4. Okay, so if you compare this to our parent function, you will see that this graph is wider because of this 2. okay, which is what you want to see. And that's it.